Hello you guys, welcome back to another episode of Physics. In this episode we're going to talk about the angular momentum chapter, and this will be our last chapter on this channel. We had some fun times together. We had a very, smooth ride. Get it. But this chapter is very easy, straightforward chapter. I think personally is one of the easiest chapters in this whole book. Some of these problems up for angular momentum are very straightforward and very simple. All you have to know is you need to know your trigonometry. You need to know the basic equations, and you'll be okay. And some of them, they teach you how to do the right hand skill, but most of them you don't need to use it. Some of them they're very, very, very strange to use that. But let's go hit our problem today. And our problem of today, we have a bullet of 400. That's the initial velocity is going 400 meters per second, and has a mass of 0.2 kilograms. And it went through this log right here. This log is made of wood, I guess. And this log has a length of 4 meters and has a mass of 300 kilograms. Not 300, 30 kilograms. I'm sorry. And as we can see, the bullet went through the log, and it has a final velocity of 200 meters per second. This shows that the bullet transfers some of its energy to the log here, making it move. And the question is asking, what is the angular velocity of the log when the bullet went through it? So it goes whoop. So I know that initial angular momentum is the initial angular momentum has to be equals final angular momentum, and I know that for the initial angular momentum, I know that inertia of the bullet times the angular velocity of the initial of the bullet plus the inertia of the log of the angular velocity initial of the log, and this will be 0 because initially this log is just standing there doing nothing, and this has to be equals to the inertia of the bullet plus of the log, plus times the angular velocity final of the log plus in the inertia of final of the bullet times the angular velocity final of the bullet. Now to find angular momentum here, I know that velocity of the tangent is equals r times omega, and omega is equals velocity of the tangent times divided by r, and r is equals to the length So I know that if inertia is ml squared times v, velocity of the tangent divided by L plus 0 has to be equals to 1/3 of the mass L squared, and this is what we're trying to find right here, is the angular velocity of the log plus ml velocity t final. And if we move this to this side and we multiply 3 to this side and move this to this side, we're gonna have something like this right here. And right there, right here, right now, it's just a plug-in game where you take all your values from here and plug it in here, and what I get at the end is I get 2.2 radians per second, and that's the problem of today. Very simple problem. Some problems are more difficult than this one, but this is personally, if you know how to do this problem, you know how to do all of them, because most of them have the same concept as this one. So I wish you guys luck. I know next week will be finals for most of you guys, and for whoever's watching this, good luck. Thank you.